Good morning, everybody. Just got my board completed. I want to just review the areas on the board. And I only had to add 3 wires. And compared to the original board, I've added this board now can stack, so I can have these connectors here allow me to have a slave board underneath this one, which only has the optos and the power supplies here, the drivers and the FETs and the caps. It doesn't have this logic or this logic. It has the connector to the output transformer, and it doesn't have any of this logic. The master has everything. The master has a switch here that lets me select either 5 count or 10, so I can have 5 negatives and 5 positives caps discharging into the transformer primaries, or I can have 10, so it gives me a sequence of 10 of each, so I get 10 positives and 10 negatives. I added these delays here for the enable lines to get rid of glitches, because there's a timing issue from the NE55 timer over here out through the counter and the decoder to the buffer chips. And what happens is if you don't have delay in the enable line, the enable is occurring at the wrong time. So I need this data points here on these 3 244 buffers. I need the enable to occur once the data has settled. So I added these 2 delays for the 2 groups of 5. And out here I've added a comparator, 741 comparator, and previously I just did a posting of how I had wired the negative 12 over here, needed to be wired in instead of positive, and then on the positive side was totally good, except I had the 2 and 3 backwards on the 741 over here. What this circuit does, this allows me to monitor an output on the transformer power. There's a power supply charging up a cap, positive and for this side and a negative for this side. And what happens is once that cap reaches a certain level, which is adjustable with this pot, then this FET discharges that cap back into the pre-charge for these here and these here, positive or negative. And I can have, so in other words, I can start with 12 volts on my pre-charging with pushing these 2 buttons, either plus or minus 12, and then I can actually increase that voltage into the pre-charge line to the caps by monitoring the output transformer. One of the secondaries will run a separate power supply. What this also does, I have also here a negative power supply and a positive power supply. The secondary comes in here on each of these, and that will allow me to generate also a positive and negative energy to replace the batteries out here. And with a little luck, based on Tesla's transformer knowledge, the output out here, if I can tune it, resonate it, have the pulses occurring at exactly the right time from the cap discharges, the whole system should be self-running. And so with that energy out here maintained by the board with no batteries attached, means that I can then take this energy and then create more energy from this, and then perhaps run a car or run the house or whatever. But the first goal here is to get this board running with the batteries to start it, and then eliminate the batteries altogether. And so far so good. The only changes I had to make on the back side here were there's a couple of wires I had to add here for the pin 2 and 3 on the 741 backwards, and then I had to add the minus 12 coming in to this comparator here, because I had connected it to positive 12 on its input. It's supposed to be negative. And that's that. And then the slave board slave board is basically the same thing, only the slave board has all of the logic removed, and the only thing I need for the slave board is the output connector to the transformer, and then the caps, the FETs, drivers, and optos, and then the battery connections here for the pre-charging. And that's it, really. It's just a matter of just doing it and putting the wires in. This board here, these connectors connect, let me stack these two boards together, plus I need to add a couple of wires for the pre-charge on each side from the two boards too. Anyway, that's it, and have a great day.